Analyzing data displays. A data display shows us a lot of information about the measures of center, such as the mean, median, and mode, and measures of variability, such as the range, such as the minimum, the maximum, the quartiles, but we can also determine a lot about the data that was collected by looking at a data display. So let's look at this example. We have the most recent test scores of some 6th grade students. So first, let's find the mean, median, mode, and range. So the mean is 77, that's the average, that's finding the sum of all those numbers and dividing by how many there were. The median is 83, that's the middle number when all of the numbers are lined up from least to greatest. The mode is 70 and 83. 70 and 83 occur more times than any other data value. And then the range, which is the maximum subtracted with the minimum, or the minimum from the maximum, is 53. Now, if we graph this in our first data display, a histogram, we notice that the histogram is not symmetrical. It doesn't have an even amount of data points on each side. It's kind of, the data is being pulled, most of the data is towards the right, but the data is being pulled to the left because some students scored lower. You can almost see, you can draw and think of your data and see that it is, most of the data, it's higher to the right, but you do have a little bit of the data to the left. It doesn't make a symmetrical mountain. And then you can see that the median is here in the data and the mean is there in comparison. So the mean and the median are not very close in this problem. The mode is not the best choice to describe a data set because there can be more than one mode. And then the range only tells us what the difference is, but does not tell us how well most of the students performed on the test. So we have to be careful of which measure is the best to really look at the data, but we can see, looking at the data display, the comparison of the mean and the median and how the data is distributed. So now, after the test, some students decided to retake the test to improve their grade. And here we have the following are the new scores. So we have now, with these new scores, a new mean of 82, and we can see that that is now very close to the median, which is 83. So if we take a look at these scores on a histogram, the mean and the median are very, very close together. Now notice that the histogram is more symmetrical. You can see it looks more like a mountain where you have the top of the mountain in the middle. The data is more symmetrically distributed because the scores are closer together. So when you're analyzing histograms, it's very important to look at this distribution, and then you can compare the mean and the median without actually calculating their values. Now let's look at a box and whisker plot. The box and whisker plot above shows the number of minutes students spent doing homework last night. We can see that the median, this line here, is closer to the minimum rather than the maximum. We can see 25 is closer than 15 than it is to 45. This means that 50% of the students that spend under 25 minutes on their homework probably spent a similar amount of time to each other. On the other hand, the other half that studied more than the median time probably spent very different lengths of time on their homework. That's because, again, you have that median closer to the minimum than the maximum. The difference of now the lower quartile and the minimum is 5. We have 15 and 20, and that shows that 25% of the students shared a similar amount of studying time that was less than 20 minutes. That means the data is then concentrated. The difference of then the maximum, 45, and the upper quartile of 35 is 10. This shows us that those students spent a very different amount of time, so the whisker is longer even though it represents 25% of the class. That's how your whiskers can look different. This data wouldn't be symmetrical. Now let's look at a dot plot. Here we have students that are asked to record the number of hours they volunteer doing community service per week. So you can see we have the number of hours per week, and then remember in a dot plot, we have each X representing one of the students. So first, let's calculate the mean, median, mode, and range. So we have a mean of 3.9, a median of 3, a mode of 3, and a range of 9. So let's look at the dot plot itself, and knowing those now measures, does the dot plot look symmetrically distributed, and then why is the mean closer to 4 than to 3? Think about how does that symmetry or not symmetry affect the mean and the median. Well, the dot plot is definitely not symmetrically distributed. Although much of the data is concentrated around the median, it is pulled to the right because of the few students who volunteered many hours. We have those with 7, 9, and 10, where most of the other students are volunteering between 1 and 5. Therefore, that mean is going to be greater than the median. The median is more going to be concentrated in that data, where the 7, 9, and 10 are pulling that mean closer to 4, that 3.9. It's a little bit higher than it should be. So whether looking at a histogram or looking at a dot plot or looking at a box and whisker plot, we can see this idea of the symmetry and get a better idea of the mean and the median and how they're related to each other, which is a better representation of the data and what values could be affecting that or causing that.